Stress activates both the sympathetic nervous system and the HPA axis in the human body. The sympathetic nervous system affects a large number of organs, including the heart, lungs, liver, and intestines. The HPA axis releases a number of hormones in response to stress. Cortisol helps give the body more energy in response to an external stressor. You don't just sweat after exertion. Your body also releases tiny amounts of sweat in response to arousing stimuli. Unpleasant things which you don't have much control over lead to stress. Work is a source of stress for many people. Epidemics caused by viral and bacterial infections have accounted for several million deaths over the past few centuries. There are a number of things you can do to counter stress, such as maintaining a healthy work-life balance. Wearable devices can also help manage stress by monitoring physiological changes. The human body is a system, and we can use system theoretic concepts to discover underlying phenomena. Brain activity, in addition to other signals, tells us a lot about a person's mental condition, such as workload. Functional near-infrared spectroscopy measures blood flow changes in the brain and can be used to identify mental workload. The hormone cortisol is released in pulses, and blood cortisol measurements have an impulse profile. Neural impulses also underlie skin conductance signals. We can recover the neural impulses underlying cortisol and skin conductance using optimization and compressed sensing methods. We relate the neural stimuli to stress through a statistical model and use it to figure out how stressed out a person is. We use state estimation and expectation maximization to recover a person's stress profile from their skin conductance. Fuzzy logic control can be used to model stress management. We use two different real-world data sets for mental stress detection and validation. We're able to recover neural stimuli quite well with our model, and then use it to estimate a stress level. We could also recover a person's stress level as they drove along toll roads, highways, and in the city. Fuzzy control was able to lower stress when deemed too high. It was also able to increase arousal when too low. We use the deconvolution strategy for estimating cortisol pulses in patients. We were also able to estimate energy and apply corrective control to a simulated patient model. The technology could be used in deep brain stimulation therapy. We would like to extend the models in the future to include other signals and develop a smartphone app for wearable monitoring.